We're going to do some examples of determining the number of significant figures in some numbers. So first we'll start off with some easy ones. Any non-zero digits are always significant. So here we have 1, 2, 3 significant figures. Same here. We have a 0 in the middle of 2. Anytime you have a 0 between two non-zero numbers, that's also significant. So 3 significant figures. Here we just have 1 digit. Zeros between two non-zero numbers are significant. Now here we go into another rule. Leading zeros are never significant. Any zeros on the left of the first non-zero number are never significant. So here we're looking at just these 3. The 0 in between is going to be significant. Leading zeros, not significant. So here we just have 2 significant figures. Now here we have the sandwich 0, so that one's going to be significant. And then we have a trailing 0. So the rule with trailing zeros is we say, okay, is it after the decimal place or before it? Well, since this one is after it, it's going to be significant. So this will be 4 significant figures. Same thing here. These 3 obviously are significant. And then 2 zeros after the decimal place. So those are also significant zeros. 5 significant figures. All right. Leading zeros are not significant. Trailing zeros after the decimal place are. So we have 3 significant figures. Leading zeros are not significant. So we're left with just 1 significant figure. Okay, so now we have these 3. The sandwich 0 is going to be significant. And then we have trailing zeros. But where's the decimal place? This is a comma. The decimal place is here. So these trailing zeros are before the decimal place, which means they are not significant. Okay, so this is just 3 significant figures. Now here, all of these zeros are between 2 non-zero numbers, which means they're all significant. All right, it's like you had a ruler, and on each division, it just happened to fall on a 0, and then here's where your uncertainty is. Okay, so this would be 1, 2, 3, 4, 5, 6, 7, 8 significant figures. Now here we have a whole bunch of leading zeros. Those are not significant. A trailing 0 after the decimal place, so that is significant. So here we have 3 significant figures. With this number, we have no leading zeros. We have a few that are sandwiched. These ones are significant. And then we have some trailing zeros. These trailing zeros are before the decimal place, and so those are not significant. And we have just 5 significant figures. Okay, so now we have a few examples in scientific notation, which makes it even simpler, because this part is all that is doing is moving the decimal place. Okay, moving it 18 places to the right, 4 places to the right, 5 to the left, 2 to the right. It's not affecting the number of significant figures. So for numbers in scientific notation, in proper scientific notation, all you're going to do is look at this part. And it's very straightforward. Everything you show is going to be significant. And the reason for that is because you always have a non-zero digit, the decimal, and then any other digits. Okay, so this one is never going to have any leading zeros. And the trailing zeros are always going to be after the decimal place. So that means everything there is going to be significant. Everything there, they're all significant figures. 1 significant figure, 2 significant figures. Okay? Hopefully that will help in determining the number of significant figures in a variety of numbers. Let me just add one more example to this list for clarification. In this number, we have trailing zeros, and there's one before and two after the decimal place. But even though there's that one before, we're looking at the whether there's any after, and then all of those trailing zeros together are significant. So this would be 4 significant figures. So you're never going to say, well, okay, those are trailing zeros and that one's before and these are after, and so they're treated differently. No, they're always going to be treated the same in one group. So this will be 4 significant figures.